Good morning, gentlemen. Hope you are enjoying your semi-snow day today. So I decided to give you asynchronous work this morning since we have class first period. And the material, as I've said, is a little bit dry. I think you can understand it, so I thought this might be the best way to go and to give you a little bit of break instead of having to show up first period on a snow day. In the book you read about finding a circumcenter. In the next few sections, we're going to learn about finding 4 of these different points, which are called points of concurrency, the first of which is called the circumcenter. So here's an example problem like you are going to do. So I'm asked to find the circumcenter of a triangle with these 3 coordinates. So the first thing I'm going to do is set up a coordinate plane for myself to be able to work on. I prefer to use the sticky here. My grid lines aren't small enough. I want to count a little bit more, so I'm going to change my paper a little bit there. So we'll start with putting in our coordinate plane and simply plotting the points. So here's -2, 1. Here's 2, 3. Here is 4, -1. And I'm going to connect all of those to make my triangle here. So now, we learned in the section that a circumcenter is the point where all of the perpendicular bisectors of the sides of a triangle come together. You might be asking yourself why we're doing this, and the answer is just to see if anything interesting happens. So we're going to do different things to the sides of the triangle, and just to see does any sort of mathematically interesting occurrence happen. And here it does. So in order to do the perpendicular bisector, a bisector means cutting the side in half, and perpendicular means going the negative reciprocal slope to that line, making a 90-degree side. It's easy for flat lines like the bottom here. I can see that this side has a length of 6, so the halfway down that line will be 3. And perpendicular to it, since it's a horizontal line, perpendicular to it will be straight vertical. That one's really easy. The next 2 are a little bit more challenging. If I go to this right side here, I can see that the slope of this line, I'm going to go down 1, 2, 3, 4, and to the right 2, 1, 2. So that is a slope of -4/2. If I want to go halfway down that line, that means I'm going to go down 2 and over 1, so halfway is right there. If I want to go perpendicular to the line, well, perpendicular to that, so this reduces to -2/1. We know the perpendicular slope is always the negative reciprocal of the given slope of the line, so the perpendicular slope is going to be +1/2. I flip it and I make it positive. So to go +1/2, go up 1/2, right? That's outside the triangle. I'm going to go the other way, down to here. And there's my perpendicular bisector. You can see that looks like a 90-degree angle happening right there, as it does here. In theory, we already have our point of concurrency happening right here, but I'm going to do it to the third side just in case, just so I'm checking it out. So my slope is 1, 2, 3, 4, 1, 2, 3, 4. So my rise is 4, my run is 4. Halfway up that will be up 2/2, so that's right here. And then the negative reciprocal of this, well, 4/4 is just 1. So if I flip that, it's still 1, but I'm going to make it negative because it's a negative reciprocal, so it'll be a slope of -1. So down 1/1, and of course I'm going to end up with crossing at that same point. So this is a perpendicular bisector, and my point of concurrency is happening right here at 1, 0. So that's my answer. Just if you're curious, what's interesting about a circumcenter is equidistant to all of the 3 points of the triangle. So if I measured this distance here, and this distance here, I would actually make spokes of a circle that can touch all 3 points of the triangle. A little bit hard to draw. I missed it by just a little bit here, but you can hopefully see that, which is kind of interesting. So the problem that you have to do is exactly like this one. Do it and submit it, and throw me a like or a follow if you've liked what you've seen today. Good luck.